so let's get into where we were at. So we're going to talk about writing absolute value functions from a graph is where we should be at right now. Okay. And did I only give you the one set of notes? Did I give you is that the last one you guys have? Did I copy the 3.2 or no? No, I only gave you the one. Okay. I just want to make sure I know where I'm at so that way I know what I have to make sure I have ready for you tomorrow. Okay, so take a couple of minutes right now. I want you to read that to yourself, okay? Even with all the complicated math stuff that's in there, take a couple minutes and just read it to yourself. Bottom of page 63 is where we're at. Give you about 30 more seconds to read. Okay. I've let you skim it over. We're not going to read every little word together. I'm going to more explain it than anything else. Okay. We are not going to mess with the B thing. All right. Just like we didn't mess with it when we were looking at the parabolas. Okay. It ends up, because it's very hard to tell between a vertical stretch and compression and a horizontal stretch and compression. So we're not going to mess with it. And it's an Otis assignment that I wrote, not HMH, not Delta Math. So it's one that I regulated exactly what you have to graph and what you have to write an equation of, okay, and how you do it. So we aren't following the craziness of the book sometimes. Really, it's the same thing we had before. So let's, out in the left-hand column, let's write down that general equation, okay, and let's describe the parts one more time, because we've done this. We've seen it a few times, but let's just refresh our memories because it's been a week, all right? It doesn't matter what you call the equation. I don't know. Today I feel like calling it g of x. I'm going to call it g of x. Okay. And we know that there is a absolute value of x minus h plus k. That's the general form of that equation. Okay. It looks the same as when it did with the parabola. Okay. We could throw another function on there around it and it would look the same. Okay. So, the next thing let's talk about how all these parts affect it. So you guys should be able to help me with this because we've talked about it a few times. Okay. What happens with the A in front? What does that do to the graph? We can move it left, we can move it right, we can stretch it, we can compress it. What does that do? It's good. That's the stretch and compress. Good job, Bobby. Okay. What happens if I stick a negative in front? What does that do to it? Say it louder. Yeah, it makes it go down. That's your reflection, right? That's the fancy word we use for it, but really it makes it look upside down. Okay. All right. What does the H do to it? We've got left, right, up, down. That's what's left. What do we think? Yeah, that's left, right. If it's with the X, it's got to go left, right. Okay. So what's left for K? Up, down. Okay. And which one appears to change the sign, the H or the K? The H is the sign changes, right? At least it appears to. Really, it doesn't because the formula says negative, but it appears when we're writing it to change the sign. Okay. In an absolute value, what we need to watch out for is that this part right here, we can kind of count that as the slope. We can count the slope on the line. Okay. We just know that one's going to be positive and one's going to be negative. It's not going to show us that, but the shortcut is counting the slope. Okay. All right. So let us try this a little bit. Okay. And we do have to. The good news is the graphs I wrote for you, probably we don't have to contend with scale like we do with these graphs from the book. Okay. I'm going to rewrite out that equation one more time, even though it's written there for us, because I'm going to take the b out of it. So we're going to say g of x equals a absolute value of x minus h plus k. That is the skeleton of the equation that I need to fill in, or the formula for the equation. Okay. If you write it out at the beginning, hopefully you'll have it memorized by the time we take a quiz on this, likely sometime next week. I don't know. Next week's going to be crazy because you all know PSATs are Wednesday, right? Okay. And on Wednesday, next Wednesday is not late start. You have to show up at 8 o'clock. Okay. But you get out early. All right. That's the bonus on Wednesday next week. Okay. All right. Okay. So we've got g of x equals, all I have to write is x something. So that's kind of the outer skeleton of it, right? I got to figure out the slope. I got to figure out the vertex. I usually figure out my vertex first. So my vertex, I'm going to blow it up just a little bit here, is this value right here. So what is the vertex point? 2, 5. Okay, so what do I have to do to the 2? To put it inside those absolute values. So what do I need to do to that 2? We got to make it negative, right? Switch the sign when it goes in, because that's our h value. Okay, what am I going to put for k? Yep, just plus 5. Good. All right, I'm going to erase my little thing here. Now, there's a little bit of a catch. I have to figure out the slope of this line now, right? Which, in theory, I should just be able to count the slope triangle. It's not quite as easy as it seems on this particular graph, because the slope triangle is because of the way the graph is scaled. So we're just going to be really careful. Okay, I'm going to zoom in on it a lot. We're going to be really careful. All right, let's think about how many we're actually going up. Right now we are at 5. Okay, how many did I go up to get to here? 1. Okay, so that's up 1. As think about how many we're over. Let's see. Each one of these looks like it is 2. Do we agree? Am I counting that right? Okay, so how many am I going over? 4. So I am going to write 1/4 out in front. And that's it. That's the whole deal. Okay. Almost easier than a parabola because we can count the slope triangle. Is it opening up or is it opening down? It's opening up, so we keep it positive. If it helps you because you need to check things off of a list to write a plus out there, I can't mark that wrong. Okay? Or you write it down when you're kind of sketching it out and then don't type it, right, when you're typing your answer. Okay, that's it. Easy peasy, right? All right, I'm going to write out my original equation again for b. So g of x, and you can write f of x, you can write h of x, you could write y equals. All of those things are the same. Ax minus h plus k, because I'm trying to memorize that. If I write it out every time, then hopefully I'll remember it for the quiz. Okay. All right. What is my vertex point? 1, 6. Good. All right. So what am I going to write in for the h value? It's going to look like -1, right? It's going to look like -1. Perfect. Okay, what's going to go out for the k? +6. I even heard somebody say plus. Good job. All right, now we're going to find the slope of this thing. So I'm going to zoom in because, again, my thing is scaled funny. Okay. I'm going to erase this so I can kind of see better. All right. Let's see. We want to do I usually do up and down first. It looks like oh boy. Where is it actually crossing where I can see it? Not very good, is it? That's That's terrible. Oh, let's try to do it to that 3 because at least we have the point, right? Let's try to go like this. All right, so if I am talking about going up or going down, what should be out in front? Is it right side up or upside down? Upside down. So what should I write in front to represent that? Yeah, that should have a negative in front. And as soon as you see that, write it down, right? I could have written that first before I wrote my vertex. Okay. All right. So it looks like my height is scaled in 2s, but I could also look at that I've got 6 as my y value and 3 as my y value. So what does the height of that triangle have to be? 3. Good. Okay. And then that's supposed to be a 3, even though it doesn't look like it. Okay. And then my run looks like it's how much? We're going from this one to a 0, so it looks like 1. So it's 3 over 1. Okay, I'm going to zoom back out. So 3 over 1. Or could I just write that as negative 3 absolute value of x minus 1 plus 6? That works. Okay. When you're going to do your assignment, my guess is when I did that, when I typed it up, because I'm borrowing something I used last year, I probably wrote it like that versus having the over 1 on the bottom. So if something isn't checking right, try it with the whole all the way simplified version. Okay. Because I probably have the check answer button in there for you, I hope. Okay. If not, we'll figure that out, but hopefully it's there. Okay. There is a your turn there. All right. I want you to take a minute, okay, and try to write the equation of that graph. So everybody try it right now. Oh, it was a tricky vertex, wasn't it? All right. With your table partner, compare your answers. See what you got. See if you both got at least the same vertex. All right, so right now, 30 seconds, compare with your table partner. Or somebody at your table if you don't have a partner today. All right, let's check it together, okay? That was definitely not as nice of a problem as the last two, was it? I'm sorry about that. All right, I need to go in there and watch this. You know what I'm going to do right now? Like, we need to do this. Change graphs. That's my note to myself if I ever go and edit these notes. Maybe I'll actually read that and fix it for next year. Okay, I drew the black dot on there myself, right? So it looks like to me, let's talk about the x. So this would be 2, 4. Do we all agree with 5? Okay, negative 5. Perfect. All right. And then this is 2, right? Negative 2. So I think it's down 1. Do we agree with that? Okay, so how would I write that for HK? So what would I put in for the H? So it's going to, remember, it's going to appear that we change the sign. So it should look like plus 5. Everybody okay with that? All right. Okay, what about for the Y value? What am I going to put in for the K? Minus 1. Good. All right, now we got to count the slopes. I'm going to zoom in again for my slope triangle. There is no good way to do this one because it doesn't like cross anywhere and there's no like nice dot. I'm going to draw my nice dot there and hope for the best. Okay, it looks like that's about halfway, right? So it looks like I am up 2. Does everybody agree with that? About right? Okay. And then it looks like we are over only 1. So up 2 over 1 would look like 2 over 1. Am I right side up or upside down? Right side up. So my final, I keep it positive out front. My final would be absolute value 2, absolute value of x plus 5 minus 1. Okay. All right. The good news for those of you who don't like graphing, okay, is that tomorrow we start all the like step by step. How do we solve an absolute value? Okay, so we'll be back into solving problems tomorrow. All right, we are going to look at the next section here, but I'm only going to do one problem, and you're going to have, that means you get time to actually try the homework assignment here in class today. Okay, so I'm going to do example 3. We're going to cross out example 4, or this your turn 4. Okay, so I'm not using that one. If you need extra space for something, it's there. Okay, it's going to step us through a modeling problem. I don't want to just. Last year I did a lot of skipping of the modeling problems because we were in a weird situation, but we don't want to just skip them. Okay, modeling is an important skill, and we want to make sure that we don't just run away from word problems. Okay, just because they've got words in them, we got to be able to try to read it and analyze it. All right, so let's take a couple of minutes on your own. Go ahead and read this paragraph and read example 3. You don't need to read the analyze the information, just read those 2 sections right there. Okay. About 30 more seconds to read. Okay, let's compare I'm just going to talk, we're not going to read through that top paragraph again. So they talk about the angle of incidence and the angle of reflection. Okay. So I don't know, do they say straight line angle? Light is reflective of different direction from the physics. Okay. Really, so they give it to you in the picture more than anything else. They didn't say they didn't define it really well in there. So the angle of reflection and the angle of incidence. So this is the reflection piece here. The angle of incidence, what's happening after the reflection, is the exact same thing. So those two, we don't use that vocabulary a whole lot, but it's there. It's probably, if you take in physics, you'll probably see it more in physics. Okay. But you'll notice, bet you never knew this, right? When you're looking in the mirror, you're using an absolute value function, right? When we have a light source in the mirror and it's bouncing off. So there's your absolute value. That's really a stretch, but it works. All right, let's reread this part here together, because again, when we're reading through a word problem, it's always good to read it a couple of times. Okay. So Robert, can you read me the first 2 sentences, please?
At a museum exhibit, a beam of light originates at a point 10 feet off the floor. It is reflected off a mirror on the floor that is 15 feet from the wall. The light originates from.
Good. So whenever we have any kind of a modeling problem like this, okay, you need a picture. They were nice enough to start drawing the picture for us, okay? But if they don't, you need to draw it, okay? It doesn't matter how good of a bad or of an artist you are, you need to sketch something, okay? All right, so they were nice enough to show us, hey, here's 10 feet from the floor, and then here is with the distance is reflected off the floor is 15 feet from the wall. So here they gave us our mirror, and they put in the dimensions 10 and 15, okay? All right, Jasmine, can you read the last part of that paragraph there?
How high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror?
Perfect. Okay, so they gave us another dimension. They said, hey, this is 8.5, okay? And they want us to figure out this right here. That's our value that we're looking for, okay? All right, they're having us step through and set it up. We might not go through everything if I was just writing this out on my own, but this is a good way to kind of scaffold it for you when you have to do this on your own for the assignment. And I think that on the advanced assignment, I put a total of 2 problems, okay? So, but there will be something like this, similar to this on the quiz for the advanced, all right? All right, the model will be of the form g of x equals, well, guess what? It's going to look exactly like what we've been doing, right? A absolute value of h minus k, or x minus h plus k. And I picked on this one because it did not have the b value in it. All right, what is technically our vertex there? Okay, let's pretend, because it's a little bit tougher to see this, right? Let's put this on an xy axis. Okay, so let's think of it that way. And they're looking, the mirror is the vertex point. So how many is that out on the x? 15. How many is it up on the y? It's not going up anywhere, right? Look at the green dot, right? So we are out 15, up 0. So 15, 0. Now, I kind of cheated when we wrote the equations. There's another way to do it, okay, when we have a point on the graph. So I'm going to show that to you with the advanced, okay? So another point on the graph would be, I'll do it in a different color. We'll do it in blue. Is that point right there? For sure we know that, okay? So how many is that point out on the x? Good. How many is it up on the y? 10. Perfect. So that one is 0, 10. All right, then they did ask us how far is the opposite wall is blank feet from the first wall. What am I going to do to figure out the distance from here to here? Yeah, 15 plus 8.5 equals how much? Good. Okay. So it says, let the base of the first wall be the origin. So they're helping us formulate a plan. You want to find the value of g of x at x equals. So we want to find the height of the wall out here at 23.5, right? That's our value there. So that's the height that we want to find, which will give the height of the beam on the opposite wall. To do so, find the value of the parameters in the transformation of the parent function. In this situation, let b equal 1. The vertex of g of x will give you the values of, so vertex gives us which values in our formula here. Good, h and k. Use a second point to solve for a. So that's the part that we're going to practice right now. I didn't show it to you this way when we were doing our little graphing and writing the equation. Evaluate g, and then we're going to plug in the 23.5. Okay? So those of us that like the analytic piece or the algebraic piece, you'll probably like this part better. All right, first thing we got to do is write our equation. Oh, and they left it. I pulled all of their instructions out. Okay, so we're calling it, they said g of x. So g of x equals, we don't know a yet. We're going to figure that out. X minus, okay, what was our h value? We figured that out earlier. We were looking at vertex. So what's our h value? 15. What's my k value? 0. So do I really need to write that? No, I could just leave it as this. All right. Now I need another point on the graph, okay, to solve for A. So instead of reading the slope off like I was doing before, I'm gonna plug a point in. Did I have another point that we came up with? Yeah, 0, 10. So I'm going to put 10 in for the y. Remember, y is disguised as g of x. And I'm going to put 0 in for the x. So I'm putting in 10 for the y value. And I'm going to put 0 in for the x value. So I kind of color-coded there what I was plugging in. Okay, let's solve for a. And this should be familiar. We did something like this with parabolas. We did the bridge problem. We did something just like this. All right, what's 0 minus 15? Negative 15. So I've got 10 equals a times absolute value of negative 15. What's the absolute value of negative 15? 15. Good. How do I get the 15 to the other side? Divide it. Good. So I'm going to write my work up here. So I've got 10 divided by 15 equals a. Could I reduce that a bit? If I'm able to reduce the fraction at this point in our mathematical careers, we should still do that. Okay. So what's 10 divided by 15? Sorry. What does it reduce to? What goes into both 10 and 15? 5 goes in. I heard some 2/3 going on, right? Everybody okay with that? So divide both by 5. It reduces to 2/3. Now, I need the actual equation. Okay? So I'm going to take this and I'm going to plug it back in, and I'm going to plug it back into this line right here for the A. Okay? So I'm going to use that. Plug back in there. Okay? So g of x equals 2/3 absolute value of x minus 15. Yeah. Why didn't we leave 10/15ths?
No, like, because 10 was the y value, so we put it.
10 was the other point. So remember, our y value at our vertex was 0. Does that make sense? So we use this as the other point to try to solve for the A. Are we good now, Levi? Okay. Good questions, though. Keep asking them. Okay. All right. So now I am going to, I'm going to go back and read and make sure I've done everything I was supposed to do. Okay. So I always go back and I read my paragraph again. Okay. Or at least where they're asking the question. So it says the vertex gives us this. Oh, that wasn't the question, was it? How high off the floor on the opposite wall does the light hit the other wall is 8.5. How high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? So have we found how high off the floor yet? We haven't found this piece yet because I need to take this and I need to plug it back into that equation. Okay? So that's what we're going to do now. I'm going to say I'm writing proper notation, G of 23.5. All that says is I'm going to take 23.5 and I'm going to plug it into this thing. It has nothing to do with the calculation other than a label, okay? But you need to get in the habit of labeling that correctly. If we were next year on the calculus test and you just left it as X and you didn't label that, you would lose the points even if it's right, okay? So you got to make sure that you pick that up, okay? 23, I'm trying to train you well now. All right. Get out some Desmos. Figure that out. I'll give you a minute. Get onto Desmos and put it in. If you use the key on the keyboard that is right above enter, that gives you an absolute value. Not that I think you need it on this one, but. All right, did we get a number? Did we do the whole thing? Did we do 2/3 times that? So do 2/3 times that mess. All right, now what do we get? 1.56? Anything else? 5.67. Okay, I'm going to put it in, and let's make sure we're all doing it right, okay? I want to make sure that we... Oh, good. Now it's going to be small all day. Gotta love it when it does that. Okay, Desmos. All right, I would type... This is what I would type in. 2/3. I would probably do this. Watch. F of x equals... Not that. 2/3... Absolute value is above the enter key. So I just typed that. Absolute value, it was x minus 15, right? Remember, if I type it like that, then I can plug whatever I want into it by saying f of 23.5. Okay. I could also have come in here on this line and just done 23.5 there and gotten rid of my f of x part. That's also valid. But if I had wanted to plug in more than one value, the first way is better. Okay, so 5.667. So we go 3 decimal places. So we'd probably say 667. Okay, the 3 decimal places is getting you ready for next year. All right, I'm not going to do justify and evaluate. Let's just cross that part out. Okay, we would probably want to label this in, I think it was feet, right? At least get a label on there, feet. Okay, I told you we were going to get rid of the your turn. So that means we're done with that part. Yay. Okay. I'm not going to keep going on anything today. What I want you to do is, if you look at the weekly assignment for this week, okay, I put it out there yesterday. There is an Otis assignment you could be working on right now. And there is an HMH assignment you could be working on. So this is more like the second example. This is more like the first couple of examples. And it adds the graphing in there to help you review the graphing again. Okay. So right now, open those up. We're not working on anything else. We're trying those 2 assignments right now because you know how important the homework is, because where do I get the test questions from? The homework. Okay. So you practice it right now. So everybody's opening. You've got about 15 minutes or so. Get that open. Get started on it. Okay. It's rare that we get extra time in here. I'm going to shut that off and see if I can get it to reset itself. So while you guys are working. Okay. If you've got a question on something, please let me know. Okay.